Alright, so today I'm going to work on a video regarding graph transformations. I'm privately tutoring a student, not at the moment, but every week. And right now she's working on graph transformation. So I figured I would do this video specifically dedicated to her because, oops, marked there, because she is my student. But also, if anyone else understands transformations better because of this, then that's wonderful. So the first question says, the objective of a computer game is to break a brick by deflecting a ball towards them using a paddle. The graph shows the current path of the ball and the location of the last brick. You can move the paddle up, down, and left to right. At what coordinate should you place the paddle to break the last brick? Assume the ball deflects at a right angle. So this isn't too clear to see. It is a little blurry because for whatever reason it wouldn't let me save the picture that was sent to me. But regardless, obviously she has a copy, so it should be okay, and hopefully you can kind of see it good enough. All right, so I guess I'll start in red. We have this path that the ball's currently taking, and the ball's right here. Okay. Now this paddle, I can move up, down, left, or right, and I want to intercept this green ball. I made it green, it wasn't green in the picture, in such a way that it deflects off of the paddle to hit that brick. So this guy is going to come down, and at a particular point, it'll follow the path and smack the brick right here. So if we look over here at, sorry about that, my iPad went down, but anyways, if we look over here at this left portion of the line, if we were to look at that, we see it crosses at right here. So it crosses the y-axis at 0,8. And if we make note of the slope, you go down 1 over 1, down 1 over 1. So that's a -1 slope. So if I was looking at just this left portion of the graph, then I would say, ignoring, let me make that a little smaller. If I ignored this right portion over here, if I ignored that section, this is y equals -x plus 8. It has a slope of -1, and it crosses the y-axis at 0,8. Now, with that in mind, this portion over the brick side over here, that's going to have the exact same slope. Now, it's going to have the same slope because it assumes the ball deflects at a right angle. So, right angle. So because of that, it's going to have the same slope. Now, if we were to look at this graph, the fact that it has the same slope, and really just by looking at it, this V-shaped graph, we should know the parent function is the absolute value of x. And maybe I can make a video on the parent functions another time, but hopefully you're familiar with this. Okay, so that is our parent function, and we need to intercept it and make sure it hits the brick. So following this, basically what I did here in pink, right here, is I'm making a slope down 1 over 1, down 1 over 1. And I'm just following that into the projected path of red here, where the ball's going, to see where they intercept, because they both will have the same slope. And this point where they intercept is 7,1. Okay, so the one coming from over here The 7 coming because it's between the 6 and 7. Okay? So for the first part, it says where should the paddle be placed? So it hits the brick. 7, comma, 1. I think it already has the comma there, but that's our coordinate point. Now, part B asks for the graph, or the equation of this graph. Because if I were to put the paddle here, which is what we would do, right? We would put the paddle right here. This is no longer a parent function. Well, it would not be our parent function to begin with because the parent function is at the origin, right? If I were to draw a coordinate axes, right, this would be our parent function. This is shifted to the right 7 units, and it's shifted up 1 unit. So the way we would do this transformation is we would say y equals the absolute value of x. And what did we do to it? Well, there's 2 transformations. There's a shift right 7 units, and there's also a shift up 1 unit. Okay, so we shifted the whole parent function to the left, or to the right, I'm sorry, 7 units. And the way we denote that is just by putting a -7 inside our absolute value bars here. Okay, we use the minus to go right. If this were a plus, it would have been shifted to the left. But we don't want that. We want it to be minus. It's also shifted up 1. So the way we do vertical shifts is we just do whatever it says, up 1 plus 1. If this was -1, it would go down 1. So this graph right here is our thing. And let me see if I can find here it is, Desmos. So we can actually graph this function and see it. Y equals the absolute value. We're saying it is x minus 7, close the absolute value, plus 1. Well, just like in the picture, we see it crosses here at 8, right? It goes down, it goes down, it goes down. It hits at 7, 1. And then if we were to go back to the problem, I know it's not easy to see, but the brick right here is at 14, 8. That's the coordinate point of the brick. So if we look here, we need to go to 14, and then you can see it's 8. So this is our graph. I was just graphing this so we could see it, but it also kind of helps confirm that we did this right.